Hello, everybody. Let's see here. Hopefully, everybody can see me. I'm just going to give a moment for everybody to start showing up. Hello. Let's see here. Refresh this. Brought to you by Mountain Dew. Hi, Athlon. Just give a few moments for other people to start showing up before I start doing my live thing. If there's anybody, my intent for today is to be talking about the Commodore 64 and my experiences with the Commodore 64. So if there's anyone here who has any specific questions about C64 development and so forth, let's see here. Edit this. See. There. I went ahead and put up a little post there. All right, I'm going to go ahead and start beginning. Of course, I'll be recording this for the home audience. Hi again, it's time for another episode of Burgertime, and this is my third installment as I'm getting more and more, how to say it, more and more experience at doling out all this drivel that I seem to do every week for some strange reason, maybe egotistical, maybe crazy, mostly crazy. I would really go with crazy. But then again, those of you who know me know I'm crazy, somewhat. But here's what's going on. Years ago, I used to work on, one of my first computers that I programmed for was the Atari 800 using an Apple II as a host. But when I started working at Boone Corporation in 1982 and 83, my job was to take these Atari 2600 games and port them over to the Commodore VIC-20. I wrote these games, Chuck Norris Super Kicks and Robin Hood. Both of these games were originally done on the Atari 2600 for the Atari 2600 for Zonix, XONX, and that was actually a brand name of K-Tel. Now, those of you who are old enough to remember, K-Tel was a record label that every weekday they would have all these infomercials about now new from K-Tel. Here's all these albums and stuff like that, where you'd buy these collections of songs for $19.95 mail order via a TV ad. And for some reason, they too, like everybody else, was trying to get into Atari cartridges. I mean, hell, Quaker Oats, a cereal company for crying out loud, was making Atari 2600 games under the name US Games, I believe. Yeah, I'm pretty certain it was US Games. But the thing was is that we had, in this case, K-Tel, a mail order record company, which is just one step away from being the shopping network, was doing Atari games. Well, since at that time, in the years 1982, 83, the market was already starting to crash, people were trying to recover by doing computer versions of their games. And that's where I came in. I took these games from Zonix for the 2600, went through the 2600 code line by line, and translated them into Commodore VIC-20 code. Then later on, I went ahead and did Commodore 64 ports. And I was using an Apple II for doing all of my development, and which I wrote all the source on the Apple II. I then after I compiled it, I had this little card I designed, which I don't seem to have handy around here, in which I plugged in my Apple II, I plugged it into a 1541 disk drive, and it allowed me to directly write sectors onto a Commodore 64 disk, which then I took the disk, plugged it into a real Commodore 64, and ran the games. And the VIC-20 games, I believe, VIC-20, I think I was doing those on cartridges, because I recall they were like 4K ROMs with 2K of RAM or something like that. It's very, very small amounts of space. And then when it's going on to the floppy disks, of course, the Commodore 64, 64K, and the floppy disks had, I think it was 160K storage. See, Atari was like 90, Apple II is 140, and Commodore, I think, was 160. And I remember they had variable length sectors where some tracks had more data and inner tracks had less. But this is all coming from memory. I went ahead and I love the Commodore 64. I loved its simplicity, but it, to me, was never a computer. I know there's probably people right there in the audience who are going like, blasphemy, burner at the stake, the witch, the heretic. But to be honest, it's that the Commodore 64's hardware was designed to be cheap. The Commodore 64, if I recall, was retailing for like $3.99, $4.99, which sounds like a lot of money, but when you're comparing it to the Apple II, which was being sold for $1,295 in that range, and the Atari 800, which is about the same price as the C64, the C64 of all the computers at the time was the most inexpensive. And there were certain tricks that you had to do in order to work with the Commodore 64 in order for you to do get it to do anything. Examples is like the Commodore 64 had a video graphics mode in which it was 2 bits per pixel, so it only gives you 4 colors. But it was a weird mode which was kind of like a text mode, shall we say. Because in text, you have an 8x8 cell, and each 8x8 cell is a single character. And the Commodore 64 had 2 screens. One was the actual text, A, B, C, D, E, F, G. But the other screen, which is only 4 bits per byte, it's kind of weird, but that's how it works. Work with me here, was the color. So you would say, in this cell, any images that were on was going to be this color. Otherwise, if it's 00, it's the background color. And then there was 2 other colors which you could set with other registers. It's a really mishmash, but the thing, actually no, that one, there was other buffers. There was one buffer that had color 01, 010, and then the other one was the 11, which is a 4-bit image, and then you had 00, which was the background color. But it allowed you that every 8x8 cell, you could choose 3 colors out of your 16-color palette in that little cell. And then the background color covers everything else. So essentially that's why it's 3 colors, not 4. But with this and a lot of cleverness, you can actually get 16-color images at that low resolution in low memory on a Commodore 64. And I had to do a lot of gymnastics in order to make some really good full-color art. An example is like with Bard's Tale, the main image of the game had a bitmap with all the colors for everything for the main background, but there was colors individually for the text on the bottom. And then the actual monster picture, we would just change the background colors whenever we changed the picture. So, and then of course where the icons were for the flame, monster, stuff like the shield, stuff like that, we had different color sets there. So the image looked full 16 colors. It looked very pretty, especially when I was doing Bard's Tale 3, because Bard's Tale 3, I actually had colors animating with the images as well, so that colors could be, it was a fully animated image in full 16 colors, and people going like, how'd you do that? I animated the colors too. But that's the first thing. Doing the graphics in and of itself is weird per se, but back then hardware had to be very simplified and had to be use as little memory as possible, because back then, see, even 64K, the Commodore 64 was unheard of. A low-cost computer with 64 whole K of memory. I mean, back then Apple IIs came with 16K, and you had to buy 2 banks of memory extra and plug them in and with little jumpers in order to get 48K in main memory, and then you had to buy this card which gave you the other 16K with bank switching. The Commodore 64 was right out of the box, 64K. With the Atari 800, it shipped with 16K as well, but then you had these giant cartridges you had to plug in to get 16K memory. And of course, well, Julius will show you the piece of hardware I have here. This is my Commodore 128. What I'm showing you This is the Commodore 128 I used to write Bart's Tale 3, and I used to write, so yeah, it was Bart's Tale 3, and I also did a couple of disk utilities and things like that on it, on this one. Because, you know, when I first did my games like Tracer Sanction, Mind Shadow, Borrowed Time, I only had C64s because C120 hadn't come out yet. But, yeah, this thing had 128K in there. But the biggest problem is that when you're doing development on a computer, you know, doing software development, you have to be able to have high-speed floppies or a hard drive, some way to back up everything. Because this work, if that floppy with your source code gets lost, you're screwed. I mean, you are so screwed. So I always kept backups of my games. I had I had this routine that every Monday morning when I came into work, which I pretty much lived there, so yeah, whatever, I would grab a stack of blank floppies. I'd just copy all my work onto the blank floppies. I would mark them, and I would put them in a drawer next to the burgers. Put a little foil near so they wouldn't get spoiled. But after a week goes by, I would get a new set of floppies. And I would keep doing this over and over until I had like about 6 or 7 sets of floppies. And then that's when I started recycling the earlier ones, saying like, okay, these discs are like 6 weeks old. I'll never use these because I have 5 other copies of better and better versions. So that's how I was doing my revolving backups. See, that was my way of doing source control, so that therefore I would never lose my file. Now I just noticed a reader here, Schubinator, he's asking, how hard do you think Pirates was? Schubinator, I'm going to have to ask you to rephrase your question, because when you say how hard, are you asking how hard it was to write it? In that case, I have no idea. I had no involvement with Pirates, Sid Meier's Pirates. I'm thinking of, if you think about playing it, I don't even remember playing it. I know I played it, but that was like 25, 30 years ago last time I played it. So unfortunately, my memory isn't good enough to remember how hard or how easy that game was. So I'm sorry, I can't really answer your question, Schubinator. Anyways, back to what I was saying, is that for developing, I had to write my code, put it in that case, Merlin assembler, put it on all these source code disks and so forth. But of course, how do you get it from an Apple II into a Commodore 64? And that's when I did the disk drive trick. Because other tricks people had been using that I've seen is that you actually write it on a Commodore 64. By the way, that's my wife, Janelle, who's walking by. There was several assemblers that were available on the C64 that some people were writing on. I know that there was a thing called Merlin that was available on the Commodore 64 but that was later in development. But what other people did was that they used a PC with a cross assembler, and then they wrote the code, and then what they usually did was they burned it onto a ROM, and they plugged it into the ROM cartridge. As an example, earlier when I was showing on my earlier episodes, showed my Apple IIgs and what was inside of it. You had all these slots. Well, the slots, of course, hook up to hard drives, serial cards, other things. And, of course, in my case, I had a cable which plugged to the disk drive. This is one of the reasons why the Commodore really didn't take off as a development system. Those are your expansion slots. Granted, it's upside down. Of course, here you have, let's see, try to remember this. There's your video, which I don't believe it's VGA. I believe it's a variant, but it looks very simpler. But that is the video card. This is your expansion slot, which is, there weren't very many things put together. Cartridge slot to plug in video games or other software. And, of course, this is for the cassette tape, which at the time the C128 came out, there really wasn't that much out there for cassette interfaces, but some people use it. Then, of course, you had your serial port, and then you had your, let's see here, composite video. So one uses composite video. I'm probably pointing the wrong one, composite video. And then the other one was your serial port, which is not RS-232 serial. It's a wacky clocked serial port that they designed. That's how you talk to the 1541 drive. And in fact, I reverse engineered that protocol, which was how I was able to write the software to drive my card that let me talk to the C64's disk drive. The keyboard. Most computers, there's actually a CPU of some kind in the keyboard. They actually didn't do that with the Commodore. What they did with the Commodore is that there was a UART, kind of like a parallel port in which you had 8 bits which tell it which row you want of the keyboard to read, and then you had an input of 8 bits, and it was a crosshatch. So what you would do is that you would set 1 bit, and it would allow you to read the 8 keys, then the next 8 keys. Now, of course, that meant that you had a maximum of 64 keys in your keyboard, but also at the same time, it meant that I could read any key I want at any time. So I could press as many keys as I want and let go of them, and I can completely track them all. There were issues with writing software on the C64 because of debouncing, i.e., I push a button and sometimes the electrical curtain might spike, so you might think you pressed it twice, or it might cause some noise that makes you think that you pushed the other button. So you had to you had to read it a couple of times to verify that it was stable before you said, yes, this person actually pressed that key. And there was no capability on this keyboard for me to do interrupt drivens. That is, I couldn't say, my software could go blah, 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 like that until you press a key and an interrupt would occur and I could read the key. It doesn't do that. I actually have to have, in my case, I usually did like a video blank where it would, at 60 times a second, there would be an interrupt. I would scan the keys, figure out what it is, and then I would send a keyboard event to the main games software. The Apple II actually had this port where you just read from it and it would just tell me the key I pressed. And as soon as you read a key, then you hit this other port saying, yep, I got it, and then the next one would be available. Much simpler from the software point of view. I mean, the Commodore, I had that write a couple page, but at least about a page, 256 bytes of code just to read the keyboard. Creepy Dead Boy, C64 forever. Okay, I'm going to answer some questions. Schubinator's saying, about pirates, write it, and I expect you to not have written for it. And he goes, it's a speculative question. Well, Schubinator on pirates, writing pirates, I really have no idea how they wrote the game. That's really a question you need to ask Sid Meier and his team. My speculation was that either he wrote it using an Apple II or possibly a PC, or then again, he may have written a Commodore. I really don't know. See, back then, development systems were about as unique as the programmers themselves. I mean, we went ahead and wrote a lot of, we wrote a lot of our own custom tools to work with the assemblers and compilers and things like that based on how we work, because there really wasn't anything standardized back then. It wasn't until like the mid-'80s when Merlin really became a good standard. Then it was Orca M APW on the 2GS, which was another standard. There was Merlin that came out on the C64, which became very popular. And I understand why. It's a really great assembler. But then later on, EA pushed this thing called the Artist's Workstation. This happened around the mid-'80s, late '80s, in which they standardized all development was going to be on PCs. And then they would push the software from the PC onto the Apple II, the C64, the Atari 800, the Amiga in some cases, Atari ST, because the whole idea is they wanted to have everybody using a PC so they can exchange files and art and so forth, instead of having to say, okay, artist has an art file on their Amiga, but I need to transfer it to an Apple II, which would then turn it to a Mac file, and then you could put it on the network. It got old real quick. With the C64, it's, the machine itself was a really nice machine to play software on, really, games and so forth. But as a development system, there's very, very few people that I knew professionally back then who was actually using a Commodore 64 for development. Now, I'm going to show you something that's really fun. I've mentioned in a previous episode, and I'm going to reiterate it now, that one of my games later on in my career, in the mid-'80s, I standardized everything on the Apple II, including my libraries and my libraries and my file system. And I actually did a fake ProDOS on the Commodore 64, because what I was doing was I actually wrote a file system translator for my 2GS that actually allowed me to take a 1541 disk drive and mount it as a floppy drive on my Apple II. So that my development system, all it really did was just say, oh, there's a device called 1541, just copy files to it like any other device. So I didn't even use any special software anymore except for this device driver. And then what I did was that when I created a floppy disk for this Commodore 64, I wrote a fake track, which had a Commodore 64 disk drive track on it, which had the directory so that it would look like a normal file. But then everything else was Apple II. And I'm going to show it to you. I'm going to move some folders around. Give me a second. Reload it. Yes. Move this here. Okay. And now go to... Okay. All right. Now I'm going to change screens. I'm going to show you the code to this. Now let me go ahead and zoom in if I can. Whoops, that's not changing the font. That's actually just, well, let me see if I could change something here. Let me go add a scene. Give me a second, everybody. Video capture window. All right, and I think I got it. Okay. All right, what I'm going to do is I'm going to tell this to... I'm definitely going to be editing this later on. Okay, oops. All right, so let me see here. Can I do this? Order. Just bear with me here just for a minute. Fit to screen. Set size. Just trying to get this thing working. Okay, can my viewers see this? Because I am not sure you can read this. And anyways, let me get back to what I was trying to say. If anybody can see this. This is a disk image called Task Times in Tone Town from Activision. Let me zoom it in. All right. Okay. As I'm totally trying to fix this. Let's see, position site. Don't mind me. That's one thing about live TV is you get to see my mistakes all the time. Let's see here. Anyways, here we go. Here is something called RWTS, Read Write Track Sector. On this, okay, let me get back to this is the file Task Times in Tone Town Disk 1 for the Commodore 64. This is an actual sector dump of a floppy you could just download off the internet or grab it on the internet or look on an actual 1541 drive. What I've done is that there's an actual file, a folder which has a file called Read Write Track Sector. That's what RWTS. That's actually a throwback to the name of that particular piece of code on the Apple II. This is an index to the actual file I use to read in the 1541 drive. Then I have a thing called ProDOS, which is essentially a reverse engineered copy of ProDOS that I wrote that runs using a 1541 drive. Then here's advent.system, which is the actual file name of the game. Then the interpreter, which is the interpreted code. The code to handle Windows. Here's the code that handles the actual, it's actually all the data in the game. And then here's the animated picture at the beginning of Task Times in Tone Town. And then here's the initial splash screen, which says Task Times in Tone Town. But these are, if someone looks it up with an Apple II floppy disk for ProDOS, you'll find that these are ProDOS sectors. And then in the middle of the disk, if I can get to that, here we go. There we go. This is the actual at offset 16500 and then 16590. This is the actual fake track for the Commodore 64, which tells you that the disk's name is Enio, and that there's one file there called test times. And what that does is it just simply points to that program, read write track sector, which does the fake boot of a ProDOS disk. Let me get back to my web feed. So back then, I was literally making my games all using an Apple II file system on all the computers, so that when I wrote the game, it could assume I was using Apple II file names, Apple II directories, Apple II everything, even though it wasn't an Apple II. And now I have some questions. People are asking questions, so I'm going to go there. Someone says, wow, didn't know about the original Commodore. Yep, the keyboards were done as grids. Troy in Atlanta says, hi, Burger Becky. In Bard's Tale 3, why was the harmonic gem drop break almost 0 and the encounter rate was so high on the Amiga version? Will your PC port be more like the C64 version for those things? The answer is very simple. The Amiga version, while I started the project, it was taken from me and given to somebody over at Electronic Arts. So therefore, I didn't get to finish the game, nor did I have an opportunity to actually debug it and test it and balance it. So for both the PC version and the Amiga versions of Bard's Tale 3, I didn't get final say on them. So as a result, there were bugs, there were balancing issues, and so forth. The version that I'm currently doing from In Exile, which I am, right now in alpha stage, is that it's all based on the Apple IIgs version, which was based on the original Apple II versions. There will be no balancing issues. If there was any balancing issues in the 2GS versions that somehow people haven't told me about, then they probably will still exist. But any balancing issues from the Amiga version or the PC versions will not exist because it's not based on that code at all. Schubinator writes Artist Workshop, referencing Apple II. Okay, referencing Apple II from Schubinator. What did the B in B run mean? Was there anything else? B means binary. Run is the command on the Commodore 64 that would tell you to load a program, and same with the Apple II, by the way. It would tell it that when it loads a file in, it doesn't know whether it's an assembly hex file or an AppleSoft BASIC, or in this case, Commodore BASIC. Commodore BASIC is a bunch of special tokenized commands. In other words, it's a byte that means run, a byte that means list, a byte that means print. And then with line numbers and other stuff that's like, ooh, like deep magic, ooh, I'm scared. But it's binary data as far as the computer is concerned, so it has to rely on you telling it which is it. Is it BASIC or is it code? Now, when you tell it to run, it's supposed to say load the data in, but then it goes to the BASIC interpreter and say go. And that's how your basic programs work. 10, print, hello, 20, go to 10. Very simple. But for binary, is that it loads it in, and whatever the first byte of that hex image is, it just jumps to it and starts executing. And at that point, you're going to cross your fingers and hope things don't explode in a fiery ball of flame. And of course, with the Commodore 64, the commands to load a file was was load space, quote, space, the name of the file, or asterisk meaning the first one, quote, comma, 8 meaning the drive number, and then it was an optional comma 1 meaning read from the file the first 2 bytes telling me where to put it in memory. But if you just told to run, it just assumes everything is just a big basic file image, loads it in, runs the basic interpreter, and if you mix and match, it's going to explode. And trust me, I've seen some spectacular explosions. Schubinator asks, are there any run commands? What about the load? But load never worked on B run applications. Okay, on the Commodore 64, to auto-run in a program, you typed in load, space, quote, asterisk, quote, comma A, comma 1, then hit return. How do you know that? Read the frickin' manual. If you don't know that, then you should take your Commodore 64, put it back in the box, take it back to the store, or in this case, back to the Goodwill or wherever you got it, and tell them, get me a Mac. Next one is Troy Atlanta goes yes, and one side of screen, small but readable. Um, don't know what that means. Oh, it's probably for the text I was doing earlier. But back to Commodore 64 development. Um, one of the things that Commodore 64 had is wide adoption. It was cheap. Lots and lots and lots of people had Commodore 64s. In fact, at the time, we, as much as we sometimes didn't really care about doing a Commodore 64 version of our games, we had to because that was where the money was. While Apple IIs were very popular with hobbyists and gamers, Commodore 64s, there was easily like 10 times as many Commodore 64s as there were Apple IIs. At least people buying them, or at least buying games. Let me just elaborate. People bought games on the Commodore 64 anywhere from double to 10 times as many as we ever had on the Apple II. And it's not necessarily because the Apple II wasn't a better computer, it's because people sometimes bought the Apple II because they were only going to use VisiCalc on it. They don't play games on it. It's a business machine. Just like you see in lots of PCs these days are being used for running screen at airports or using them running a cash register and so forth. I don't think you're going to be installing a copy of Bard's Tale on them. So you really can't count those PCs that were sold to be used for them as potential machines to sell a copy of a game onto. Same one with the Apple II. While the Apple II did sell about maybe 1/3 or 1/4 the number of the Commodore 64 sold, that number was still dwindled even further because of the number of Apple IIs being used for business. Now, not to say that some people used their Commodore 64s for business. Many people did, but they were such a small percentage compared to people who bought C64, gave it to their kids, or somebody used it as a cute little video game computer. And C64 was a wonderful computer. I mean, it had a great sound chip, the SID chip. I love programming music on that thing. In fact, I'll play a little bit for you. Ooh, look familiar, everybody? Let's go ahead and load. I wonder what I have. The problem is that the keyboard isn't mapping completely to the PC one-to-one, so I have to sometimes guess what it is. Let's see here. What do you mean file not found? Let's see here. Make sure it's got the. Make sure it's got the disk image attached. It should. Okay. There we go. Now this is really hilarious. This is how you read a catalog on a. That's how you read the catalog on a Commodore 64. You load it in as a program, like a basic program, and it prints it out. It's like, what the hell? But and then again, you know, you just go with it. Let's see. All right. All right. There we go. But anyways, as I was saying earlier, that's the fake track. Those files, there is no file called task times, and there is no file called 1.1. Those are totally fake. What it's doing is it's going to the remapped directory where I had copies of the ProDOS disk, and read-write track sector would then load it all in and get it going. I hope you guys can all see this, because unfortunately for me, I'm not really seeing what's on Twitch TV properly. Let me see here. See if I could refresh Twitch TV on my end so at least I could see it. Oh, there we go. La la la. One big problem here is that the Commodore 64 does take a little while to run. Hopefully it's not dead. That would make me sad. Maybe it is dead. Let me reset it, because it shouldn't take this long. There we go. Load. Okay, it says it's trying to load something, so the little red light's blinking. Oh, give me a break. What's funny is I tested this earlier today, and of course here it is on live TV in front of everybody here. It's not working. But what I'm trying to do is I was trying to load Task Times in Tone Town so I can have it play the intro music at the beginning of the game. Well, while that's busy doing its thing, I'll turn it back on when it actually comes back to life. Is that programming the SID chip was really fun doing music, because I had, in this case, Russell Lieblich and David Warhol were working with me on composing all the music for Task Times in Tone Town. And of course, later on with Bard's Tale, I had Kurt Hayden do the music for me on the Apple II and C64 version of Bard's 3. Which also, he is working with me on redoing some of that music for the new update for In Exile, for Bard's Tale 1, 2, and 3 for the PC. See, anybody here have any more questions, or is everybody died here? But let's see, what other things I can mention about the C64? Let's see. Well, the games I worked on C64, of course, were did a game called Final Eclipse, which never shipped. I did a proof of concept back at Boom Corporation. And that first started life on the Commodore VIC-20. And then went on to the C64 and then died. It was like a first-person space game. Then there was Mind Shadow, Tracer Sanction, Borrowed Time, Task Times in Tone Town. Did a lot of the low-level work on Bard's Tale 1, 2, and of course wrote 3 completely. Then there was, see, it was like one other game I did for the C64. I think it was World Karate Championship. But it's like, I had to really look at all my source code that I did. Oh, Dragon Wars. Forgot. Duh. Dragon Wars. I did that for the C64. But it too, if you look at Task Times in Tone Town, Bard's Tale 3, and Dragon Wars, you will find all 3 of them are using that fake track sector thing in order for me to allow me to write the game once on the using the Apple II operating system, and was even using ProDOS calls, because ProDOS had this entry point where you call to issue file commands. I emulated that too. So the high-level code really thought it was running on an Apple II. And I did some conditional assembly in some places where it would use Apple II keyboard routines and joystick routines and mouse routines, whereas the Commodore 64, I use a completely different function. But the main game really thought it was running on an Apple II. In fact, the memory maps are so identical that I kind of did a hybrided memory map, and I even mapped the video memory in the same spot as it would be in the Apple II. Just changed the display drivers. But the... let's see what other things it's doing there. Oh yes, and the sprites. Oh, that reminds me of something I did. Back around the Mind Shadow years, I went ahead and did a... in fact, that I think is what the problem is with Task Times. Let me go, give me 1 second here. So I'm going to go ahead and attach this disk image. And I'm going to reset this thing. Okay. I wrote a fast load code. The 1541 disk drive on the Commodore 64 is a computer in and of itself. There's a 6502 in it. There's about, I think it was 4K of RAM, and then there was a ROM about 4K. It was in there a little computer whose job it was to read from the disk drive, read and write sectors, and respond to serial commands. And the idea was your Commodore 64 would say, give me a sector, or give me a file, or give me something. And then this little firmware would then, because it had a little micro operating system in there, would then go to the disk, read what it wants, then send the data after it's read it into its own memory serially to the Commodore 64. Fine and dandy. This makes it so the Commodore 64 could easily have a disk drive attached to it through a serial port. But it also means is that the disk drive was frickin' slow. The reason being is this. A disk is written in a circle. So that the disk, when you turn on the motor, it starts to spin, and you turn on the head and you read. And you can read as fast as the disk is spinning. The trouble was on the Commodore 64 was that after you've read in just one sector, it would then stop reading, then it would have to drop what it's doing, go to the serial port, send the data out the serial port to the Commodore, and then it goes back to the drive, reactivates the read head, and tries to read and continue on. Well, the trouble was is that by this time it's got back to the disk, it's already rotated about, I think it was like a third of the disk before it could read another sector. So that therefore, in theory, if each sector was sequential, sectors 0, then 1, then 2, then 3, like that, you'd have to rotate the disk 16 times to read 16 sectors, which could be very slow. Now, the Commodore 64, as well as the Apple II, just so you know, did a thing called sector interleaving. This trick was to work with the slowness of the software that was reading from the disk drive. And what would happen is it would read a sector, then it would be a known period of time as it rotates around the disk until it got to where it is ready to read another sector. Well, what you would do is you'd put at that location sector 2. So read 1, stop what you're doing, send to the disk drive, or send it to the Commodore 64, then you're done, start reading again. Oh, that's sector 1. Repeat, sector 2 is up here, rotate, now it's 3, 4, 5, 6, 7. So at this point, for every revolution, you get about 3 sectors. So 16 sector disks, you can read about the entire track in about 5, 6 rotations. So you effectively just doubled or even tripled the speed of your reads. Well, to me, that's not fast enough. And I'm a need for speed. I got to have speed. So what I did was that I went ahead and figured out a way that through the serial port, I can transmit the data so fast that I could do it every other sector. So I would go in there with my code, read in the sector, and as soon as the sector is read in, I would immediately transmit it to the Commodore 64. And by the time I was done transmitting it, I would be at the next sector I want to read, which would be at sector 2 physically. So 1, then it would be like, the numbering would be 0, 8, 1, 9, 2, 10. So therefore, I only need 2 revolutions to read the whole track. Now, how the hell did I send that data so fast? What I did was that I actually cycle timed everything on the Commodore 64 as well as the drive. They were running at about 1 megahertz, give or take. And what I would do is that the serial port actually had several bits in it. Now, it only used 1 bit when it was doing transmission back and forth. I was using 2. And I did what was called self-clocking, in which I would write a clock bit, which in other words I would say, ready, go. And as soon as I say that, the C64 would be sitting here going, well, wait, got it. It says go. At this point, I knew I had a window of about something like 10 cycles that the first 2 bits would be valid. The next 10 cycles, the next 2 bits are valid. The next 10 cycles, and so it was so precisely timed that I was actually able to read in all the data at something like 10 times faster than a normal serial port. Then came sprites. The problem is that the Commodore 64, this is one of those little tricks that you don't know about, but you have to do deep, dark voodoo. The Commodore 64, what it would do is that as it was clocking to memory, it would clock, the CPU gets the bus. Next clock, the video gets the bus. Next clock, CPU. Next clock, video. And this is steady. So therefore, you can set your watch by the speed of your computer. And at that point, you would have enough cycles going to the going to the GPU, i.e. the video chip, so you can display your screen. And there's enough for the CPU to do whatever it wants at full speed. Fine and dandy. Except when you turn sprites on. When you turn the sprites on the Commodore 64, sprites are these 8 little images that are read in 64-byte buffers, and it overlays it onto the screen. So you don't actually have to draw them. You could just tell the hardware to put them wherever you want. Well, the memory had to be read from somewhere. So what the hardware did was kind of clever. Every 8th scan line, it would have to take not only the CPU's clocks, but it also took it took its own GPU clocks, but also took the CPU's clocks for 40 bytes to read the color information, as well as some sprite information and so forth. But it was really noticeable on every 8th scan line. So I actually had a table on the C64 in which the way I did it to do the reads, to synchronize to video, was that I would have this table, I would read this register, tell me what scan line am I reading. I'd look at this table, and the table says true. I would then tell the 1541 drive, send me a burst. If the value was 0, which was every 8th scan line, I would just wait until the scan line changed. Because then I would be able to do the burst, because if I did it on those scan lines that were actually had sprite information and color information being read, the CPU would be going too slow during that little burst of time. And I factored that in, which is one of the reasons why my games like Mind Shadow, Tracer Sanction, Task Times, especially Bard's Tale 3, it loaded so fast because I did all those little tricks. And this is one of the things I had to deal with actually understanding the cycle timing of the hardware on the Commodore 64 in order for me to do reads and writes from the hardware into the main memory, into being able to load stuff in at will. I even, in one game, I don't remember if it was Task Times, but I even did copy protection by actually putting code into the 1541 drive in which it was reading the sectors in, and I was looking for whether the tracks were aligned properly. And I was doing it all in the 1541. So there was no code inside of the there was no code inside of the Commodore 64. In fact, I didn't even load the code into Commodore 64. I told the drive, load in the sector, from the disk using their normal system, and then I told a command to execute the code while it's still in the buffer. So therefore, all I used the C64 style was load in sector, run. But C64 itself didn't run anything. These were commands I sent to the drive. And then that's when the drive got taken over. In fact, that was that RWTS that you saw in Task Times and Tone Town. That was the sectors that were being read into the drive to do the read-write track sector on the drive side. See, anything else with C64? Other than I had Commodore actually came out with hard drives for it and a real operating system instead of that little kludge that they did with the load 8,1 kind of thing. The C64, would have had a contender to be a really good personal computer. But then again, think about it. The Commodore did redeem themselves. They came out with the Amiga. And the Amiga was, let's say, a pretty awesome computer, especially for its time. Guru meditation errors notwithstanding. I'm running out of time here, so if anybody here has any questions for me, so I can go ahead and answer them before I go crawling back under my rock. Let me see here. Let me go ahead and type into, see. Just typing into the chat room any questions. But yeah, I really enjoyed working on the C64, and in this case the C128. Another fun fact about the C128, there was actually a Z80 processor in this thing. Was it this one that had Z80? Because I know that one of the models had a Z80 in it so it can run CPM. The only thing I was kind of disappointed in was that it didn't allow you to have the ability to run the Z80 CPU at the same time that you're running the 6502, because then I would have had a field day writing code for both CPUs at the same time. But it was one of those things that was meant to be. I mean, I'm certain it was a marketing decision, kind of like what they did with the Apple III. Because when the Apple III came out, they had this Apple II emulation mode, but when you were in that emulation mode, all the Apple III features were disabled and you couldn't even access them. So you couldn't write, let's say, an Apple II program that said, oh, if you're an Apple III, I can use this extra memory. I really don't understand why marketing people do this kind of crap, because it really hurts in the long run, because it's like, you spent the money on your computer, you spent the money on your hardware or your game. Why does somebody arbitrarily tell you what you can and cannot do with your own computer? I mean, I could see some things for security reasons. Like an example is, what if you had a machine that could play Xbox One games? Of course, that feature would be locked tight to keep people from copying Xbox One games. That, okay, I can get behind that. But if you've got this extra hardware, then there should be an ability for you to say, hey, I'm running as a PC, and I got this great Xbox One GPU. Why can't at least I use that as my video chip? Why disable the hardware, or why make it disappear? Now, granted, if it's an Xbox One mode, of course, I'm just making this stuff up. But if it was an Xbox One mode, why would it lock everything out? That's what happened when they did with the Z80 processor, CPM for the Commodore 128 and the Apple III extended modes. When you were in the old compatible mode, they disabled all that. And I'm like, you have a Z80 processor. I want to be able to use that on my Commodore 128. You could do a lot more stuff there. Yes. Someone here, I can't really read the name. Let's see here if I can get it. Creepy Dead Boy writes, ComVex 2015 was last week in Las Vegas. Commodore Business Machines engineer Bill Hurd was there and had lots of great stories of development of C128 and various processors it contained. Yeah, I'm certain he has. I mean, I wasn't at Commodore at all, so I'm certain his stories probably trump mine. But what I do know as a developer was that, when I'm hearing that there's this new machine from Commodore with a Z80 processor in there, with a lot more instructions, plus that if I could use it and the Commodore 64's 6502 processor, actually 6510, I think it was. At the same time, the mind boggles with the hacks I could have done. But they pulled the rug out from under me. And lo and behold, when you were in C64 mode, that hardware is gone. You literally had to power down the machine, power it back up in C128 mode, and run C128 exclusive software in order for you to use it. And it's like, dumb. Okay, Alphalon. I'm sorry I'm mangling your handle. Alphalon or Alphaleon. You're right. It sounds like a lot of your development work involved creating workarounds for very strict hardware and/or software limitations. Do you have a sense of how much effort went into the hacky workarounds versus developing actual gameplay? I would say easily about 30% of my time writing Commodore 64 code was workarounds. And not necessarily workarounds, it was how to make the machine stable, how to make it when you play the game, you're not complaining to me why your keyboard isn't working right, why your disk drive isn't working right, why is it so slow? I mean, like as I was trying to load right now, Task Times in Tometown. In fact, let me try again because I actually did a. There we go. When I was, all these things is like the floppy disks are slow, the reading of the keyboard unreliable, the there were so many things about the system because it was built cheaply. They cut so many corners and they relied on software to fix it. That when we were writing software that turned the ROM off and we had to write everything ourselves, we had to do all that trouble too, which unfortunately caused the code A to be complex and B to be error correcting, because we had to constantly figure out how to read. And anytime we tried to think outside the box, like if we wanted to read from the 1541 drive using the standard serial port, it worked fine. But if you wanted to go fast, then you had to start learning little tricks. And of course, for many developers, they would be wondering like, gee, I have this code that was reading data in a burst, but it works only most of the time. Sometimes it didn't. And they couldn't figure it out. Me being a hardware engineer, in addition to being software, I then figured it out logically what was going on and ran some tests. I wrote pieces of software that what it did was count cycles. And then I realized that it was changing on every 8th scan line. And then when I looked at the hardware and did the counts, I was like, so that's what's going on. It's reading the color memory on these lines, and it's reading sprites on these lines. Now it makes perfect sense. And once armed with that knowledge, I was able to then make the hacks to make the 1541 fast load work. Frimples writes, I had a 1581 3-point-inch floppy drive for the 664. So much space. Yeah, it's amazing how you have a disk that's 5 1/4 inches in diameter. Let's see if I have one handy. Well, I have a flop. Actually, I do have a disk somewhere. Oh well, it's up on the shelves there. But these little floppy disks had 800K, or then later on when they went to the HDs or the PCs, 1.4 meg. But then again, this is 64 gig. 1.4 meg, 64 gig. We've come a long way. And with that, it looks like I've run out of time, but I will be back next week. And next week, I'm going to be talking about Bard's Tale. So I'm also hopefully going to be showing off of the game in progress, and hope you guys are going to like it. And if there's any other questions and stuff like that, another hour of my mindless, meaningless drivel. So I'm going to be signing off right now. Anybody else? Any last questions? Okay. Oh, yeah. Okay, somebody's saying, oh, yeah. I guess you're talking about, oh, yeah, for my Bard's Tale. Yes, I will be showing off stuff from Bard's Tale. I will be showing some of the code. I will be talking about its development, and also letting you know the current progress of the updated port. That all of you any of you who have pledged for the Bard's Tale 4 Kickstarter will get a copy. And those of you who haven't pledged, you can easily go to InXile's website and pledge, because they will honor it and they will let you get the copies of the games if you pledge for Bard's Tale 4 at I think the minimum page 25 to get a copy of the game. But then again, things change. So whatever this is broadcast, or wherever you watch this, just go over to the NXL website, and I'm certain that you'll be able to get a copy of the games, especially if it's like, if you're watching us in 2016 or later, you can just download it off of Steam or wherever it is they're being distributed. But hopefully you'll enjoy it. Frimples. Wasteland was 8 sides, and you had to copy all 4 discs. Oh, don't get me started on Wasteland. Oh, please don't get me started on Wasteland and how that was developed. I think I'll talk a little bit about that over at next week's show. But there was a huge difference in how the games were written, which was the reason why Wasteland and Bard's Tale technologically were vastly different. All right. Anyways, I'm going to be signing off, and I hope to hear from you all very soon. And we'll go ahead and on my YouTube channel, please make sure you subscribe. And on my Twitch TV, make sure you follow me. And also you can follow me at Burger Becky on Twitter. Or you can follow our company, Old School, OLDESKUUL, on Twitter and on Facebook. So hopefully hear from you soon. All right, take care, everybody. Bye.